This talk is on haloalkanes, which includes CFCs and halons, the chemicals that damage the ozone layer, as well as their potential replacements, or the replacements that are currently existing, HCFCs and HFCs. The first thing we need to understand is what is a haloalkane. A haloalkane is just an alkane, which is basically a hydrogen and carbon chain with single bonds, which contains halogens, which are obviously elements from group 7 of the periodic table, including chlorine, fluorine, bromine, iodine. Our CFCs we talked about already. They're the chemicals that we know have diffused into the stratosphere and caused damage to the ozone layer. They're called CFCs because they contain chlorine, fluorine, and carbon, and they're called chlorofluorocarbons. A similar chemical which has also caused damage to the ozone layer is halons. Now, halons were chemicals that were typically used in fire extinguishers before they banned CFCs and halons. And halons are very similar to CFCs. They contain carbon and they contain halogens, but the key feature is that halons contain bromine and typically contain no hydrogen. Similar to CFCs, they have no hydrogen either. So halons contain bromine, and in actual fact, halons were worse than CFCs as far as damaging the ozone layer concerns. They are worse than CFCs for ozone decomposition. So they were banned as part of what we call the Montreal Protocol, which you'll learn about later. So both these chemicals damage the ozone layer. And just a quick refresh, we know the ozone layer is the layer that exists within the layer of the atmosphere called the stratosphere. Well, obviously because CFCs and halons were so damaging they had to be banned, but that meant they needed to find replacement chemicals because they were doing useful jobs in refrigeration and fire extinguishing, and they needed new chemicals to replace them. And the two groups of chemicals that have been used to replace them are HCFCs and HCFCs and HFCs. So these chemicals are the replacements. Before we look at why they use these chemicals to replace them, one of the things to remember about CFCs is that CFCs, being so stable, were able to be produced in the troposphere, and they diffused all the way to the stratosphere. And within the stratosphere that they encountered UV light, because all the rest of the UV light had been blocked by the ozone layer, and that caused them to decompose into the chlorine-free radicals, which we know decomposed ozone. So the replacement chemicals, the first strategy they approached was it's got to be a very similar chemical. It needs to be a gas with a low boiling point and relatively safe, which is why they went for HCFCs. Now, HCFCs are very similar to CFCs, but HCFCs contain the elements hydrogen, chlorine, fluorine, and carbon, and they're called hydrochlorofluorocarbons. And obviously the main difference between HCFCs and CFCs is that HCFCs contain hydrogen, and the fact they contain hydrogen means they are more reactive. And the fact that they're more reactive meant they were more likely to decompose in the troposphere. The troposphere being the layer of the atmosphere that we exist in, the layer closest to the Earth. And that meant that HCFCs diffused upwards through the atmosphere, but a lot of them decomposed before they reach the stratosphere, and therefore before they reach the ozone layer. Unfortunately though, some of them still do reach the ozone layer, and because they contain chlorine, the ones that do reach the ozone layer, that contain chlorine and encounter UV rays, they still produce chlorine-free radicals. But we say they have less ODP than CFCs. Okay, ODP stands for ozone depletion potential. Because a lot of them do decompose in the troposphere, they have less potential for decomposing ozone than CFCs do. And they still have some ozone depletion potential though, which means we need to find preferably a replacement that has no ozone depletion potential, and that replacement is HFCs. And if you've cottoned on to the color coding here, HFCs obviously contain hydrogen, fluorine, and carbon, and that looks pretty redundant, those three same letters, but that stands for hydrofluorocarbons. The key feature of these is they have no chlorine. And the fact that they've got no chlorine means that they've got no ozone depletion potential. Having no ozone depletion potential is obviously a good thing, because that means that we can use them without risk of damaging the ozone layer. Unfortunately, they do have some downsides. Both HCFCs and HCFCs, even though they have less or no ozone depletion potential, they actually have a high GWP, which is not so good, because a high GWP means global warming potential. These chemicals are thousands of times more potent than carbon dioxide at trapping heat in the atmosphere, and therefore they're one of the chemicals that's at risk of causing global warming and then climate change, etc., etc. The concentrations of these gases will be much less than carbon dioxide, so carbon dioxide is still the main and most serious global warming gas or greenhouse gas, but still these have a high global warming potential. The other disadvantage is that sometimes these two chemicals can't do exactly the same things that CFCs did. They are slightly more reactive, which means that they're not quite as low toxicity or low reactivity or low corrosivity as CFCs, and there's some applications where we haven't been able to replace the CFCs completely, which hate CFCs and HFCs. But it should be pretty clear the reason why we've moved from CFCs to HCFCs and HFCs is because these chemicals have less or no ozone depletion potential. And the global or international agreement that's heading us towards moving from CFCs to HCFCs to HFCs is something called the Montreal Protocol, which is widely being claimed as one of the most successful international agreements ever. And that's an agreement where many nations in the world all agreed that they would phase out and ban CFCs by a certain date, and then phase out and ban HCFCs by a certain date, and move to HFCs. And you'll be studying the Montreal Protocol as part of your research.